lonely over there. They're coming on. Yeah, I'm isolated.
Tell me the first step.
Factor.
There's actually only one here. 7. Now we got to clear out the fractions by multiplying by the LCD. Let's see, and remember, if you see 2 in there, just remind yourself. Well, we need an x minus 7 in there, and we need a 2 in there. So we're gonna, the LCD is going to be 2 times x minus 7. And then I've got to multiply that by 2x minus 9 over x minus 7. Then plus 2x minus 7 times x over 2 equals, one more time, 2 times x minus 7 times this last fraction, 5 over x minus 7. Clear your denominators out and multiply what's left. So those go. And I am left with 2 times 2x minus 9, which would be 4x minus 18. Twos go here, and I am left with plus x times x minus 7. Minus 7x. X minus 7 is here, and I'm left with 2 times 5. Now what? Okay, I mean, what would you try to? All I heard was that. Oh, hey. Okay, simplify. Is that what you said? All of a sudden you're shy. Okay, so we can combine that. Now what? You're right. Why do we have to do that? Because it's a quadratic. So we got to swing this over here. But write it in the correct order. So x squared first, then minus 3x. The 10 comes over, minus 10, minus 18 becomes minus 28. And again, it's with these ones, just like with the radical ones, you'll be able to factor them. So if you get something that you can't factor, you've made a mistake somewhere. Like the only time I'm going to get you to do the quadratic formula is if I just give you a straight quadratic at the beginning. Okay, but whenever, remember, when we solved radical equations earlier this year, sometimes they turned into quadratics. When we solve rational equations, sometimes they turn into quadratics. Those will always be factorable. Okay, so just a little sort of something to know. So therefore, minus 7 plus 4, which means our solutions are, and are those okay? Checked against the NPVs. No. The 7 is not. That's an NPV. So it's gone. So our only answer is -4. Okay. And the last one. All right, so it looks like we've got some work to do here. we've got factoring to do. Before we state the NPVs, you can factor on the right-hand side. And again, this is one of those where you can kind of use the rest of the question to help you. Like, chances are, when you factor this, it's going to have one or both of the other ones. Otherwise, it's a really hard question. Like, if these were two completely different factors, you would have a very nasty equation. Very. So you got to figure it's got to have one or both of these in it. So that maybe helps you to factor. In fact, it has both of them. Again, just sort of a little thing that you can look at to sort of help you along. We got a couple NPVs here. 6.3. And what am I going to multiply everything by to clear out the denominators? X minus 3, x minus 6, or x minus 6, x minus 3 on the baseline. So again, this is sort of the big step here. Okay. So those go. And I'm left with x minus 6 times 9, or 9 times x minus 6. Anybody? Here's the one you got to watch out for. Because it's minus 4 times x minus 3. It's not plus 4 times x minus 3. Or you don't go 4x minus 12 and then put a minus in front of the 4. This is the same as minus 4 times x minus 3, which is actually going to change this to minus 4s plus 12. Watch out for subtraction signs there. Here, those go, we're left with 18, no quadratic, so it's just a straightforward equation to solve. So I can simplify the left-hand side to get minus, what, 42 equals 18. Move the negative 42 over by adding 42, and I get 60. Divide by 5, x equals 12. Not an NPV. We're good. Okay. Okay.